In this video, let's talk about product and quotient rules that we can use specifically for functions that are made up of product or quotient, and sometimes we can simplify and sometimes we cannot, but we'll practice this. As you notice, here is the rule, but this is not how I memorize it or how I remember it. The way I usually remember, if you have a product of two functions, any two functions, even later if they're exponentials and logarithms, for example, except the constant maybe, so disregard the constant, but any other function, if you have a product, I usually remember as the derivative of the first one times the original second plus the original first one times the derivative of the second. So you alternate them like that, and this is how I kind of recall it at different times. So for example, if you have a product of 3x squared plus 2, we'll call this the first function, and 2x minus 1, which would be the second function, how would we have performed the derivative? Well, notice this is before I rewrote it. Let's first take the derivative of the first function, which is derivative of 3x squared, which is 6x. Then derivative of 2 is 0. So 6x is the derivative of the first function times, notice how I kept 2x minus 1 as the original, plus, now we keep the 3x squared plus 2, and we take the derivative of the second function, which is simply just 2. And then here we can simplify. Notice how I drew this arrow to distribute basically the 6x to the 2x minus 1. And then here the 2 is kind of the backwards distribution that we can distribute and collect like terms. Okay? Which will get 12x squared minus 6x plus 6x squared plus 4. And collect like terms, so we'll get 18x squared minus 6x plus 4. So again, take the derivative of the first one, keep the second, then keep the first one, take the derivative of the second, and that's it with the product rule. Okay, same idea here. 5x squared minus 1 times 4x plus 3. How would we take the derivative? You can pause the video and try to work this out if you haven't already. How do we do this? Derivative of the first function, 5x squared, will give us 10x. We keep the 4x plus 3, plus we keep the 5x squared minus 1, and derivative of 4x plus 3 is just 4. And then we distribute very much the same way and collect like terms, and that's how come we'll get the final answer. Notice, even if you have a square, a little later we'll learn how to use chain rule with something like this, because you have a function within the function. But sometimes with something as simple as a square, you can rewrite it as a product, which is basically 2x minus 5 times 2x minus 5. And then you can treat the function, basically the first and second function are the same, but it would work the same way. So derivative of 2x minus 5 is just 2 times 2x minus 5 plus, keep the first one, 2x minus 5 times 2. And then you can simplify it on the next page. So we'll get 4x minus 10 plus 4x minus 10. So we'll get 8x minus 20. Okay. Next example was a little challenging only because it had negative exponents, but the idea is exactly the same. What would be the derivative of the first function? It would be negative y to the negative 2 power plus, minus 2y to the negative 3rd power. And then you keep the original second, plus you keep the original first. Derivative of the second function would be negative 6 y to the negative 4th power, and then plus 20 y to the negative 5. And again, it looks intimidating, but if you just use FOIL and work it out very carefully, it still works out. So we'll have negative y times 2y negative cubed. Notice how you can just add the exponents. So we'll get negative 2y to the negative 5th. And you can do the same process to the rest of them and collect like terms. And that's how come at the end you'll only have 3 powers really, negative 5, negative 6, and negative 7. And those are the like terms. Okay? So that's a little bit more challenging, but that's kind of the idea. Quotient rule, again, instead of memorizing this rule, which looks complicated, the way I remember it, first square the denominator. So original denominator, I usually take care of the bottom first. I square it. And I very rarely expand this out, so usually I keep it as a square. Now the top, notice it's sort of set up similar to the product, how we start with f prime of x. So usually I think of this as derivative of the top times the original bottom minus, that's the difference from product, there is a minus, then I usually do the derivative of the bottom first and then times the top. So I do it a little differently from the product rule. I do the derivative first only because it's simpler to distribute that way, okay? But that's kind of the idea. Let's say if we have a function of 6x plus 1 over 3x plus 10, let's see how we compute the derivative. So again, the bottom is squared, so I do that first, 3x plus 10 squared. Then what's the derivative of the top? Well, it's just 6 times the bottom, 3x plus 10, minus the derivative of the bottom, which is just 3, times the top, 6x plus 1. And then we just distribute it and work it out. So again, if you just remember it this way, it makes it a little bit easier. What happens a lot of times when you have x over x, that the leading terms would cancel. This happens quite a bit. So we have 18x plus 60 minus 18x minus 3. Notice how x's cancel out. So we end up with, I believe, 57 over 3x plus 10 squared. And that's it. So it looks intimidating at first, but once you get used to it, then it gets a little bit easier. Same idea in the second one. 5 minus 3t over 4 plus t. So again, the denominator squared. And then take the derivative of the top, which is just negative 3, because 5 goes away, times 4 plus t. And the derivative of the bottom is just 1. But remember, there was a minus in the original, in the rule. So we have minus derivative of the bottom, that's 1, times 5 minus 3t. And then we simplify. So we get negative 12 minus 3t minus 5 plus 3t. Again, they cancel out. So we end up with negative 17 over 4 plus t squared. Okay, so that's kind of the idea. Notice here is another one. I don't know if I jumped too far. I think I did. So let's do part B first. So if we have 4t squared plus 11 over t squared plus cubed. Same idea, the denominator first, I squared. And then the derivative of the numerator, that's 8t times t squared plus 3. And then derivative of the denominator, so it's minus. Derivative of denominator is 2t times 4t squared plus 11. Again, we distribute. 8t cubes happen to cancel. So we end up with 2t over t squared plus 3 squared. Okay. In number 3, in this example, it's maybe a little bit more complicated because there's no symmetry, but we'll see how it works out the same exact way. Okay. Notice how the denominator, again, I write it squared right away, and then I work on the top. So again, the derivative of the top, now we'll have two terms, which will be 2x minus 4. Notice how I put it in parentheses because it's more than one term now, times x squared plus 3. And then derivative of the bottom is just, so it's minus 2x times x squared minus 4x plus 2. And then we just work it out. So I used FOIL, 2x cubed plus 6x minus 4x squared minus 12. And then we have minus 2x cubed plus 8x squared minus 4x, which basically distribute the 2x. Notice how x cubed happened to cancel again. But we have other terms left over, which basically we had a negative 4x squared plus 8x squared. There was a square in here somewhere, right? No, we end up with 4x squared, that's correct. And then we have 6x minus 4x, we'll get 2x. And then we just had negative 12. And that's how come we end up with the answer. And I believe that's it.